I'm imagining that I have my family here around this table. I have a husband, I have got a daughter, 27, a son, 25, and they have their boyfriend and girlfriend. And normally when I come to Swaziland, I bring Finnish candies with me and do this activity with the students. Sorry for not being able to do it with you virtually. Okay, but let me show you. I just wonder if there are enough candies for all of us. Are there more candies than people? Are there less candies than people? Or is there the same number of candies and people? Okay, let's try to find out. How can we find that out? Okay, I give one candy to myself, one candy to my husband, one candy to Hanna, one to Jonathan, her boyfriend. I give one candy to Jussi, my son, and one candy to Marianne, his girlfriend. Okay, and there were some candies left. What does that mean? It means that there were more candies than people around this table. Here I applied the so-called one-to-one correspondence, which is, some researchers say, that it is one of the primary skills that people develop naturally by living their lives. It's a very powerful skill to be utilized in education if it is a primary skill. You can practice, children need this skill when they start counting. If they want to learn counting, they have to be able to act according to this principle. When I count these objects, 1, 2, 3, 4, 5, 6, I have to be able to point one object in the sequence at a time and say the corresponding number word. 1, 2, not 3, not skipping. So when children, for children to be able to count objects, they have to be able to act according to this one-to-one correspondence. But this principle is also a principle on which you can build the concepts more and less and the same number or equal number, even before children can count. And this will then be conceptual knowledge, and I think it's really important for children to learn this. You can practice this one-to-one correspondence in preschool in many different ways. One thing is that during the daily activities of preschool, for example, if the teacher wants to give one pencil to every child, she can ask a child to help. Please give one pencil to each child, every child. Or if you are putting the plates and mugs and spoons, for example, for breakfast, you can ask the teacher can ask the child to put one plate for every child and one spoon for every plate, and so on. Another activity which utilizes the one-to-one correspondence and is also widely used for children to make sense or grasp counting and the number of objects is drawing tallies. You can draw tallies of different objects. For example, all the chairs in the room. Okay, there is one chair by the computer. There is another chair next to the door. There are chair and chair by the table. Chair and chair on the other side of the table. Then at the end of the table there is one chair, and with little children there are many different ways of drawing the tallies. The most simple is that you just draw one line for each object. When I see that on the other side of the table there are 1 and 1 chairs, I can just continue like this. Another way is to group the tallies into groups of 5. So make a little space between when you continue. On the other side of the table there are chair and chair. And that was all in this room. So we can then count 1, 2, 3, 4, 5, 6, 7 chairs in this room. Still another way of drawing tallies is this: you make the little lines, but the 5th tally is drawn across the 4 first ones, and then 2. But maybe this is the best for very little children. This helps children to practice one-by-one correspondence and make sense of the number of objects. In the theory booklet, I describe the development of the number concept of little children. But a final challenge in the end of the development of the number concept is this principle of conservation of number. There is a classic experiment made first by Gregor, 1062, where he had children from 4 to 8 years old, and they all were presented 2 sequences made of blocks. All the children were able to count that in the sequence above there are 8 blocks, as well as in the sequence below. But generally children between 4 and 6 years, when they were asked, they had been counting that this sequence has 8 blocks and this sequence has 8 blocks. They were asked which sequence has more objects, or are the numbers of objects equal? In average, children from 4 to 6 said that in this longer sequence there are more objects than in this shorter sequence, even though they had counted that there are 8 blocks in this sequence and 8 blocks in this sequence. These children didn't yet have developed the idea of conservation of number. But in average, children from 6 to 8 years old, they counted there are 8 blocks in this sequence, 8 blocks in that sequence, and they answered to the question, there are the same number of blocks in both sequences because there are 8 and 8. This shows mastering of the conservation of number principle. How can you then help children to grasp this? In the resource booklet there are activities, but for example, if you present this kind of activity, you can show children that you can pair the blocks. There were the same number of blocks in the upper sequence as in the lower sequence, because there was one from the upper sequence for every block on the lower sequence. There was a student of mine who told a lovely story of her children. She had a boy, a 4-year-old boy, and then the other children were 10 and 11. And the older ones had learned to fool the little one when it was candy time. The bigger ones, the older children, were allowed to share the candies, and the little one was allowed to be the first one to choose. And the older ones had learned to put fewer candies on a bigger area, wider area, and more candies in a smaller area. And guess what the 4-year-old, which group the 4-year-old chose. Children who don't yet have the conservation of number may also think the following way. Here are big animals, and over there are small animals. How many there are? 1, 2, 3, 4. 4 big animals. 1, 2, 3, 4 smaller animals. Which group has more animals? Of course, this one. This group has more animals. But maybe you can challenge the child's thinking that for this duck, there is one little friend. For this teddy bear, there is one little friend. For this leopard, there is one little teddy bear. And for this duck, there is this animal. So each big animal got one small animal as friend. And everyone got, and no little ones were left over. So there must be an equal number of big animals, big toys, and small toys.